All right, polynomial functions. Here's one more. This chapter on polynomials is going to be another one that similar to what we've done in Algebra 1, Algebra 2, just getting a little bit deeper into it. So, reminder what a polynomial is. It's an algebraic expression that it can be written in this form here. Notice that all of the exponents are positive. None of them are ever negative. They could be 0, which would be the case when you have the constant like a sub 0. Right? All the exponents are whole numbers. There's no variable in the denominator and no variable under a radical. So here we have an example of some polynomials here. A constant polynomial would be just like a number, 12, 5, 7, 0, 18, 14.1. A zero polynomial obviously would be with 0. Reminder that the degree of a polynomial is the degree of the largest term. So for instance, with these ones we have here, we have this first one has a degree of 7. Reminder that the number that goes in front of the term with the highest degree is called the leading coefficient. So this one, the first one has a degree of 7, the second one degree 3. If it's the constant polynomial, just a number, then it has degree 0. And this last one here has degree 8. Now, even though it has 0x to the 9th power, well, what's 0 times x to the 9th? 0. So that really has no value, so you can't count that as the degree of the polynomial then. So we always see polynomials written in this form, where all the values of a sub n, a sub n minus 1, and all of them are real numbers. So polynomials of less than degree 5 have specific names, and we've dealt with all of these: linear functions, quadratics, cubics, and quartic functions. So we're going to look at all the things we've done with them recently. We're going to talk about zeros again. We're going to look at finding factors. We're going to do division, looking at solving equations, and all of those things we've done with polynomials. So the first one here is dividing by long division. So we're going to go through the process of long division with this problem. So when we do long division, just like when you did long division back when you were in about 4th grade, we put what we're dividing by, the divisor, on the outside of the division sign, and the dividend on the inside. Now, one thing you have to remember is it must be in standard form, first of all. And second of all, if you're ever missing a term, then you have to represent that term by 0. So since there's no x cubed term here, I have to put in 0x cubed. And you can put plus or minus, doesn't matter. 0 is 0. So we're going to go and do long division with this problem. So the first thing we do is we look to see how many times does x go into 2x to the 4th, or we can take 2x to the 4th and divide by x. And what do I get when I do that? 2x cubed, right? So I'll put 2x cubed, and I'm going to put it up over the x cubed term. All right, so if you remember our rules for long division, once I write it up here, that means then I need to multiply it by x minus 4. So 2x cubed times x, 2x to the 4th. And when you do it, these should always be the same, that first one there. And 2x cubed times negative 4 is negative 8x cubed. So our next step for long division is to do what then? What do we do next? Subtract, okay? And when we subtract a polynomial, what are we supposed to do? Change the sign. So we're going to change these signs. So this becomes a negative and that becomes a positive. And so this first part is always going to be 0 when you're doing these. And then I have 0 plus 8x cubed gives me 8x cubed. And then we bring down the next term. So now my focus goes to here, the 8x cubed. What's 8x cubed divided by x? 8x squared. So I'm going to put plus 8x squared up here over the squared term. So then once again we will multiply 8x squared times x, 8x cubed. Like I said, those always have to be the same. And then 8x squared minus 4 will be negative 32x squared. And once again we subtract. So when we subtract, we change the signs. So these first two, 8x cubed minus 8x cubed is 0. And negative 25 plus 32 would be 7x squared. And then we bring down the next term. Okay, and then we do that process all over again. So 7x squared divided by x is positive 7x. Put that over the x term. Multiply by x minus 4, and we get 7x squared minus 28x. So after we do that multiplication, then once again we're going to subtract, so we change the signs. 7x squared becomes negative, the 28x becomes positive. So this would be 0 again. Negative 30 plus 28 is negative 2x. And then we bring down the 5. And do that process one more time. Negative 2x divided by x is negative 2. So we get negative 2x. Negative 2 times negative 4 is positive 8. So once again, we subtract. So we change the sign. So this becomes a positive. That becomes a negative. And we have a remainder of negative 3. So what do I do with that remainder then? Gallery? Okay. All right, we put it over x minus 4. So I will say then minus 3 over x minus 4. So my answer for this problem would be 2x cubed plus 8x squared plus 7x minus 2 minus 3 over x minus 4. Ooh, that's good. That's an interesting shape I recognized. Okay. So long division. Okay. A little reminder from that. Okay. Synthetic division. All right, this is one that you were supposed to do, right? How many of you remembered how to do the synthetic division? Okay, how many of you need me to go back through synthetic division? Okay, synthetic division. All right, here's our little note here that when we're doing synthetic division, you need to remember to use the 0 for the number you're dividing by. So in example 2, that number is negative 3 because the factor x plus 3 has a 0 at negative 3. Also, your answer will have a degree 1 less than the degree of your dividend. Now, one of the things is you can only use synthetic division to divide when this is linear. Okay? When what we're dividing by is linear and the coefficient of x is 1. That's the only time you can use synthetic division to divide. Otherwise, you have to use long division. All right, so let's go ahead and set this up. All right, for synthetic division then, since we're dividing by x plus 5, the number that I use here is the opposite, or what makes it 0, and that would be negative 5. And then I list it by coefficients. The coefficient of x to the fourth is 1. Coefficient of 5x cubed is 5. Coefficient of 2x squared is 2. 6x is 6. And then negative 17. Just like in long division, if we are missing a term, then we put in a 0. Okay? So the first step is always bring down this number here. So we bring down that 1, okay, or whatever that leading coefficient is, that comes down first. Then we multiply. Negative 5 times 1 is negative 5. And then we combine them. 5 plus negative 5 is 0. Then we multiply again. Negative 5 times 0 is 0. Combine them and we get a 2. Negative 5 times 2 is negative 10. Combine them, we get negative 4. Multiply, get 20. So we have a remainder of... Okay, so our answer then, so they're asking us to divide this. So our answer to this question then is going to be, we take, the power becomes 1 less because I'm taking a 4th degree polynomial, dividing by a 1st degree. That means this 1 here on the end represents x cubed. X to the 4th divided by x, I get x cubed. The 0 represents x squared. Then plus 2x minus 4. And the 3 is our remainder. So we'll say plus 3 over x plus 5. Now, this number 3 here, this is important because we're going to be using this number later on, because it's going to tell us whether something is a factor or not. All right, so checking polynomial division uses the same process. You have a dividend equals divisor times the quotient plus the remainder. So what we could have actually done here is both of these cases, we could have taken our answer that we got, multiplied it by, in this case, x minus 4, and we would have gotten our original problem. Same thing here. We could take x plus 5 times the answer we got, and we get x to the 4th plus 5x cubed. Now, you know there's a way to check that, right? Well, you could graph, or you could check your table, all right? You could put x plus 5 times x cubed plus 2x minus 4 plus, you could put that in your y equals, in y1. Put x to the 4th plus 5x cubed plus 2x squared, put that in y2, and check to see if your tables are the same. I don't like using a graph in that case, only to see if, to disprove it right away, because you can look right away and say, oh, they don't work. But with the tables, you can see them, because if they're the exact same thing, you can't see more than one, you only see one graph. But with a table, you can see it right away, they're the same. So the division algorithm says that we have a dividend is equal to the divisor times the quotient plus the remainder. Okay? And that should make sense. It's just whatever I get, when I divide, I multiply that by what I divided by, and I get my original problem. Okay? All right. Remainders. If your remainder is 0, then it is a factor. What does it mean if I have a factor? What does that tell me? Okay, it goes into an even number of times. What else? Tells us one other very important thing if something is a factor. It also tells me if it's a factor that that's a 0. That would be where it crosses the x-axis. And so that's very important for us to remember those things. So the remainders, if the remainder is 0, when one polynomial is divided by another, the divisor and the quotient are factors of the dividend. So when the divisor is a linear function, you can use synthetic division instead of long division. Well, here they're asking, is 3x squared minus 2 a factor of that cubic function? And the only way to find that out is to actually do long division and see if we get 0 for our remainder. So let's try it and see what happens. So we've got 3x squared minus 2 into 3x cubed plus 15x squared minus 2x minus 10. So if when I'm all done, my last line down here, I've got 0, then it is a factor. If I don't get 0, then it's not. All right. So 3x squared into 3x cubed. Okay, that would be x. All right, so we're going way over here, x. We multiply, we get 3x cubed minus, oh, that's 2x, isn't it? All right, so that means I need to put it underneath the x term. Okay, so make sure you're careful with that, because this is squared. That means we might be skipping every other one then. So we subtract. Change the signs. This is negative, that's positive. So what happens to both of those parts? Okay, they cancel out. They're both 0. So now I'm going to bring down both of these other things. 15x squared and negative 10. What's 15x squared divided by 3x squared? Okay, so we have plus 5 here. We multiply, we get 15x squared. And look at that, minus 10. So when I subtract, that equals 0. So the answer is yes, it is a factor. You could look at it in factor by grouping. Okay. You could try that, Gio. All right. In this case, that works. Okay. All right, because it is a factor. All right. Not always is it going to work out that obvious. Okay. Sometimes it will, sometimes it won't. Right. The remainder theorem. If a polynomial f of x is divided by x minus c, then the remainder is f of c. In other words, whatever makes this equal to 0, which would be positive c, if I put it in for x, whatever number I get is my remainder. So in this x plus 1, if I find f of negative 1, then I'm going to find what the remainder is. So negative 1 to the 87th power, minus 2, negative 1 to the 36th power, plus 8. Wow, those are some big exponents, aren't they? All right. Now, negative 1 to the 87th power is what? Negative 1. Good. Negative 1 to the 36th power is, so this is negative 2 plus 8 equals 5. So our remainder is 5. Well, what else does this mean? Okay, take your calculator for a second and put this x to the 87th minus 2x to the 36th plus 8. Put that in your y equals. Okay, go to your table. Look to where x is negative 1. What do you get? I didn't tell you to graph it. X to the 87th power minus 2x to the 36th power plus 8. Go to the table, and at negative 1, oops, what did I put in wrong here? Oh yeah, negative 1, I get 5. Okay. If you wanted to graph it, which I wouldn't because these numbers are growing so fast, okay, you'd have to make it a really small window so that it would do it quickly. All right, you could. All right, so number 5 then, that was the one you had to do last night, right? Okay. So if I could do it 2 different ways. I could do it by plugging in negative 3, the opposite, okay, what the 0 would be from x plus 3. Or I could use synthetic division or synthetic substitution, it's called, when I'm just looking for the remainder. We would get $33. Okay. So you could use either method to find that answer. It's up to you. Plug it in. I really like using the synthetic substitution just because those are usually numbers that I can work with in my head. Don't need my calculator to do it. That's the reason I like it. So if my batteries die, left my calculator at school, my mom took them to use, I haven't bought batteries for my calculator yet, okay? Much easier to do this, okay? All right. Zeros. We've talked a lot about zeros over the last couple of years, couple of classes in here. Reminder that, oops, I don't want cream. If x minus a is a factor, then a is a 0. Okay? If I have a linear factor of x minus a, then a is a 0. Which that tells us a lot of things. If I know the zeros, I can write it in factored form. Or if I know that the factor is a 0, that means if I divide, I'm going to get a even number, or a whole number. So if we get a 0, a remainder of 0 when doing long or synthetic division, then we get a factor. Okay. So here for number 6, they ask us to show that x minus 2 is a factor of that cubic function by using the factor theorem. Find q of x such that x minus 2 times q of x is equal to that. Well, basically, all they're asking you to do is find out what you get when you divide. Okay? That's all they're asking. This value for q of x here is just Cool. Look at that. It's just what I get when I divide. All right. So let's see if it's a factor first of all. So we're going to use synthetic division, since that's easier than long division. So here's my divisor. So I'm going to use 2 in my synthetic division. So we have 1, 5, -2, and -24. All right. So when we do our synthetic then, we bring down the 1 first. 1 times 2 is 2. 5 plus 2 is 7. 2 times 7 is 14. -2 plus 14 is 12. 2 times 12 is positive 24. So we get 0 here. So since my remainder is 0, it is a factor. I'm no longer signed into my Google account. Okay, you got that? All right, that's good to know. Right. So that means then that my q of x in this case is equal to x squared plus 7x plus 12. The numbers I get here are my coefficients for my function for q of x. Okay. So when it's asking you just to find this function, well, that just says, okay, x minus 2 times what is equal to that? Well, if I divide, I know what that product is. I know what that factor is I'm going to be multiplying by then. Here's just a reminder that zeros, x-intercepts, solutions to an equation, and factors of polynomials are all related. They all refer to either the factors or they refer to the zeros of a polynomial. Number 7, is this one you did too? Okay. Says find the zeros by graphing, then write the function in factored form. So if we know what the zeros are, then all I have to do is write those, take those and use the opposite and write it in factored form. All right, so let's take a look at that here. What? No. Dirk. It's Dirk. Bradley Dirk Coffee. That would be that's where Nowitzki got his name from. They named him after me. Right. All right, I got a story about Andy Dirk. And they're not even playing right now. So, all right, so your answer here should have been for number 7 then. You would find the zeros of -2.5, 1, and 5, which then your linear factors, or writing this function with linear factors, would be x minus 1 times x minus 5 times 2x plus 5. And show you how I got D. Okay. All right. So first of all, I know that these are 2 of the zeros. Okay. These are the whole number ones. Right? So those 2 are going to give me x minus 1 and x minus 5. Okay. When I'm done and I multiply these 3 together because it's a cubic function, right? The very first term has to be 2x cubed, and the very last term has to be a positive 25. Okay? These 3 multiplied together have to equal the first term. So that means that this has to be 2x, because x times 2x would be 2x cubed. And then these 3 multiplied together equal the constant. So then -1 times -5 is positive 5 times positive 5 equals 25. Okay? So when I know the ones that are whole numbers, that really helps me. Okay? In any of them that are fractions or decimals, I can get them by using that method there. Okay? All right. And another thing is to remember that, you remember when we were doing slide and divide? Okay? So this factor here would also give me is negative 5 halves, right? So that means as a factor, it would be x plus 5 halves. But using that slide and divide method tells me that this 2 then goes in front of the x. Okay? So there's actually two methods for doing that then. Okay? All right, all right, so number 8 here says find 3 polynomials of different degrees that have negative 2, 1, and 3 as zeros. Okay? And to be honest with you, this is the easiest part of this lesson. Okay? All right? It really is, Melissa. Melissa, can you tell me how to write those as factors? Okay. If I have a 0 of negative 2, then the factor is, Melissa? If I have a 0 at negative 2, then the factor would be x plus 2, right? Yeah. Okay. So we have x plus 2. Okay. X minus 1 and x minus 3, right? Okay. All right. So I'm going to write that 3 times. Because those are my zeros, aren't they? Okay. Anybody remember when we talked about multiplicity last year? Okay. All multiplicity does is it means it happens that many times there, right? Okay. So here's the thing. I can do almost anything I want to this now, and I'll still just have those zeros because they're the factors. So I could put, oh, wait a minute. There would be 1 right there, wouldn't it? Okay. Now it says different degrees, okay? This one has degree of 3. Okay? So what could I do to g of x so that it has a different degree than degree 3? Do what? Put an x in front of it. Well, if I put an x in front of it, that means I have an additional 0. Okay? I can't do right at 0, so I can't do that. Okay? Ms. Tangman, what do you think we should do? Put a number in front of it? Okay. 5. All right? Does that change the degree? No, okay, that doesn't do it either. But it's a different polynomial now, isn't it? Okay, Kayla? Okay, I could go up here to any one of these and I can change the power. Oh, this is now degree 4. I could. It doesn't matter whether it's there or not. Not required. It just says you have these 3 zeros and different degrees. So I could make this one 8. Oh, now I have degree 10. Okay. Do it still have the same zeros? Yes, they do. The only thing is the graph is going to look different because the degree of the graph is different. Okay, I told you, that's really the easiest thing, right? Okay. All right. Okay, last one. Okay. All right, number 9. Okay, the number of zeros of a polynomial of the degree n, has at most n distinct real zeros. So the maximum number of distinct real zeros of f is 5. Oh, I think that might be easier than the last one. 5.